Yeah, I want to record a video on some normal distribution stuff. So I'm going to share this screen. All right, so this is from a textbook that shall remain nameless. So I can understand the situation. I mean, it doesn't say that this stuff is normally distributed, but I'm assuming that it's intended to be normally distributed. The first thing I'm going to do is I'm going to create a picture using a normal distribution sketcher. And I'm just going to take a screenshot, bring that over. Okay, paste it here. Okay, so this is the picture of the normal distribution centered on 1040, and I got a standard deviation of 25 grams. So you can see the steps here going up in 25-gram steps. The middle 95%, that's based on the empirical rule. So I recognize 95% is one of the sort of key numbers. Remember the first statement, there's three statements here. So one would be 68% of the bags of popcorn would be between 1015 and 1065 grams. Put my G in there. And then one more step up would be 95% of the bags of popcorn would be between 990 grams and 1090 grams. And notice that this is a statement of proportion, but it could also be turned into a statement of probability. There is a 95% chance of getting a bag of popcorn that has between 990 grams and 1090 grams. Okay. And so we turn into this proportion of customers receiving bags question. So now the 990 question can be answered in a couple of different ways. And I want to keep connecting to the graphical kind of visual representations because I think that that's helpful. So first off, the line for the 990, let me get my annotation tool in here, is here. Would have liked it to be a little bit farther to the left, right there. Perfect. And that is exactly 2 standard deviations to the left. And there's a couple of options that we have there. We can use the normal distribution tool, norm.s.dist, putting in the z-score, which would be -2, and saying that I want true. So this is giving me 0.02275. That's 2.3% or something. Remember that when I use the norm.s.dist, and by the way, the norm.dist is just different in what it takes in as the arguments, right? So I put 990, I put 1040, I put the deviation, standard deviation was 25, I put true again, and it gives me the exact same result. So this is just using the value, the mean, and the standard deviation, whereas this is using the normalized, the standardized value, the -2, which is the result of doing the x minus mu divided by sigma. Okay, so 2.3% is my answer. There's also a way to use the z-score table. Let me bring my browser over here for a second. So if I do something like z-table, normal distribution, okay, let's just click on this one. This is fine. So We've actually got two things here. This is the positive side. I want the other side, and I'm looking for the z-score of -2 exactly. And so let me use my annotation tool again. So a z-score of -2 exactly would be here with a 0 as my hundredths place. So this value here is 0.0228 is my value. And that, of course, is exactly the same as what Excel told us. Get rid of my annotation tool here, right? Just rounded to that 4 decimal places. Okay, so a couple different ways I can do that. And the graphical representation, the meaning of this picture is that the area of the curve to the left of that line and under the curve is only 2.3%. It's a very small part of the whole area of the curve, right? The whole area of the curve, remember, represents 100%, the whole population. And so we're saying, well, we really want just this little edge here. That's just 2.3%. Right. Let's work out the next one. Estimate what percentage of customers with weight bags weighing less than 1 kilogram. Oh, sorry. And I actually answered this question backwards. So this is a good example of going back to reread the question before you move on. Receive at least 990 grams. That doesn't make sense because 990 grams is like the smallest little piece, and at least means more than, right? If I have to be at least 21 to buy alcohol, then I have to be 21 or 22 or 23. So at least 990 is actually the other side of this. So this value here is giving me the wrong amount. I actually want the entire other side of this. So everything over here, which is going to be, and the easiest way to think about it is the complement of the 2.3%, which is 100% minus 2.3%. Or if we deal with it in terms of decimals, 1 minus that value. So I would take this 1 minus this. That's the decimal version, and 100% minus this gives me the percentage version of that. 97.7%. Okay. What proportion of customers would receive bags weighing at least 990 grams? Okay. I did that one. Estimate what percentage of customers. Let me delete some of this annotations. What percentage of customers would receive bags weighing less than 1 kilogram? Right. And so, but the interesting thing about this is, right, we're trying to make sure that the bags have more than a kilogram because I'm selling kilogram bags of popcorn. If I have to prove to the FDA that I'm actually giving people what they bought, then, you know, I got to make sure my machine is kind of calibrated properly. So that's where this question would be interesting. So what percentage of customers would get something less than 1K? So 1K is not one of our specific lines. It's here. And we're wondering the percentage of people who are over here. So again, thinking about this as a proportion or probability, what's the probability that that would happen? Or what's the proportion of people who are going to get that? And is that within the risk or the tolerance that I'm willing to accept? So again, I can use this norm.dist using the value as 1,000 because 1 kilogram is 1,000 grams. And then the mean, which is 1,040, and then the standard deviation, which is 25, and then I want it to be cumulative. Or I can do the work first of finding the z-score. So I do 1,000 minus 1,040, and I divide it by 25. So that's a negative number, negative 1.6, and I should get the same thing when I say norm.s.dist, and I use this z-score with the value through. Right, so same answer, either way that I'm going. So let's say that, and thinking again, and just I always like to contextualize this with a percentage. So if I turn this into a percentage, we're talking about 5% or 5.5%. What if the company said, well, not that's too big of a percentage. I'm willing to accept that 1% of people are going to get less than 1,000 kilograms. And so I might ask myself, I mean, I probably need to like reorient this so the average goes higher and the standard deviation is lower or something like that. But if I wanted to know what z-score is connected to 1%, or what value is connected to 1%, that's kind of a harder question, right? And there's some various ways that you can solve this. One of them would be an algebraic approach where you kind of figure out your z-score based on the z table. Let's go to the z table. So if I want 1%, then let me get rid of all my annotation stuff here. So 1%, 1% is 0.01. This is 0.02, 0.01, 0.0104, 0.01. So these two values are bracketing 1% exactly. This is very close. This is very close. I'm talking about negative 2.32 or negative 2.33. So once I have that z-score, then I can work backwards to figure out what the value is. Would be something like this. Minus 2.33 equals x minus 1040 divided by 25. And then I need the algebraic tools to be able to undo this. Now I'm thinking I see division by 25, so I'm going to multiply by 25. And I'll multiply both sides by 25. I'll just write 25 times over here. And then that would leave me with minus 2.33 equals, sorry, let me just do the math, equals minus 2.33 times 25. So that's going to be equal to x minus 1040. And then I can work out what x is by adding 1040 to both sides. And I'm going to write that as with a space in front of it and hope that it doesn't erase my. Let me change this to text space plus 1040. Good. And like this text. Doing algebra in Excel is incredibly annoying. So this is not like a really good use of our skills. But I'm going to take the minus 58.25. I'm going to add 1040. And that's going to be equal to my. So this is the value. And I can check by doing it. I can say norm.s.dist. And I can put in, oh, sorry, if I want to check the value, I should use norm.dist. Put in the value 981 or 982, and then the 1040, and then the 25, and then the true. And this should give me something really close to 1%. Yeah. So this is what I would have to tell people I was selling if I wanted to make sure, based on this normal distribution, that less than 1% of the population got bags that didn't live up to that claim. And I wanted to show you that there's a norm inverse, which takes in the probability I want, 1%, and gives me the z value back. So that's kind of a cool tool. So with the mean 1040 and the standard deviation is 25, I get this value, which is more accurate actually, because this was close to 1%, but there was actually a few decimals back there, right? This is actually the value that I'm looking for. Exactly. Well, I mean, there's more decimals back here. So yeah, that's an example of several normal distribution type questions, moving into using z-scores, being flexible between looking left and looking right. Let me know if you need more videos or you want to dig in further into any of those particular topics. All right, be good.